On the high road and I'm driving slow with one upper. Freeing, man's really out here in the deep end. They talk it, I live it, and they lock me.
Hello and welcome everyone. I'm Toady UK and welcome to TOADY'S Takedowns. Got a fantastic show for you today. We're going to concentrate on the phenomenon known as cold moonlight. So, without further ado, let's get this show on the road. So what's this all about? There's a number of flat earthers who say that the moon is a luminary and that it also emits a strange cold light that cools anything that it shines upon. Let's examine those claims a little bit more closely. The first claim is that the moon gives off a light which has a cooling effect, a sort of reverse heating effect, I suppose, in some ways relating to the photons that come off the moon. There must be some kind of special photon that has a cooling or freezing effect. Now, there are numerous anecdotal stories told about this cooling effect of the moonlight, and it's established now in the Flat Earth law as one of the major Flat Earth claims. It's been often debunked very successfully by the likes of Astronomy Live, Greater Sapien and so forth, and yet it still manages to return with the oft-heard and repeated phrase, "How about that cold moonlight? It's a fact, you know." So, let's take a closer look. Let's move on and listen to the White Rabbit Society tell us about cold moonlight and how we need to look for the answers outside of all known science if we're going to understand these effects.
I'll conduct an experiment which will show that the moon emits a cold light which causes objects to lose heat, thereby violating all known laws of physics and eliminates the sun as a source of this light. Although to understand why this is, a basic understanding of light is needed.
Okay, let's have a look at how he conducts his experiments. Please make sure that you notice that the temperature when he tests it in this short video clip will ramp up and down from one end, ramps up in the middle, and then down at the other end. It's very interesting that this seems to follow the pattern of the actual light that's shining on the object from this rather hot lamp that he's got above it. And also notice that we have no baseline for the starting temperature or any sort of control in this. But anyway, let's have a look at this video clip.
So that it doesn't skew the results. And the material here is a motorcycle ramp. It's a very thick piece of metal. It should work very good for this experiment. And we have an umbrella to block a portion of the metal from the moonlight. And hanging from the umbrella we also have a piece of ribbon so you can see if the wind is moving at all, which you can see it's not moving. And that's the whole setup. Okay, we're back again. The material's been in the moonlight for well over 3 hours now. You can see the moon has moved far to the right in the sky. So the part on the material on the right side has been in the moonlight for the longest, and as the moon has moved to the right, the shadow from the umbrella has moved gradually to the left. So we're going to go ahead and start over on the side that's been in the moonlight the longest, and we're going to take some readings. And you can see getting about 53.6 to 54.5.
Notice how that's heating up as you move closer to the middle.
Okay, and let's go over to the part that's been in the shade for the longest.
And where the lamp has been heating it. Oh look, it's 56. Notice it ramps down again as he moves to the left there.
Let's go back over to the moonlight side again. And let's go gradually down the length of the material.
Temperature starts to rise, rise, and rise.
We're starting to get over into the shady portion now.
The bit where the light has been on it, heating it up.
Isn't that cool? It just gets higher in temperature.
Not really, it starts to ramp down at the end, which is what he doesn't show. Anyway, let's have another look at another flat earther doing an experiment. This next one, please notice that there's a box, and the box is protecting half of the sample object, and then on the other side that is not protected. Now of course, any exposure to the wind that might be coming through here will of course contact this piece of the metal and cool it more than the other end. Also need to note that these infrared thermometers are incredibly inaccurate, especially when they're working on shiny surfaces. But anyway, let's have a look at this chap.
This time. All right, the exposed side is reading at 37.9. Let's go ahead and start moving that towards the side that has been shaded. Climb.
Let's debunk these claims and see where we get to. Okay, first off, explanations and issues with the concept of this cold moonlight. The first is that moonlight creates a really strong psychological effect. When there's a bright moon, it also means there's no cloud cover. Hence, the radiated heat from all the daytime is rapidly lost upwards into the sky. So when the moon is most noticeable, it's also when there is least containment of the heat from the day by the clouds in the atmosphere. Secondly, the tests that are carried out by flat earthers are at best faulty and at worst they're dishonest and fraudulent, with one notable exception which we will get to later. Seeking their own confirmation bias means that they test just one object, have no controls, no calibration or error correction, and the people that are doing these tests are rarely trained in scientific inquiry or experimental protocols. The third point is, the tests they do normally have far too many variables. They have objects in many locations, they have no baseline test or baseline data, they have no controls to help calibrate the environmental effects, and they also use poor equipment choices, such as the use of IR thermometers that we touched on. So, let's take a look at the test technique that I'm going to be using. A little bit more advanced, and it addresses some of these problems. First off, I'm using an accurate plus or minus 0.2 degrees C thermometer with a solid sensing probe to avoid any of the false readings that you might get from an IR thermometer. Second point, the shade that I use is at least more than 1 meter away from the sensing probes. This avoids the issues with a covering effect around and on top of the thermometer. The third point, the two thermometers that I use, the control, the one that's in the shade, and the one that's in the moonlight, are swapped partway through to make sure that any device calibration issues are negated, because obviously they're swapped. And finally, the data collection that I'm doing avoids any moving or touching of the thermometer, so we get no false positives from the heat of my hands or the heat of the body or some other effect. So let's have a look at how I've been sampling the data in these tests.
Okay, here we go again. In the moonlight 5.2, not in the moonlight 5.2, they're doing pretty well actually.
And there we see the setup. It's really very, very simple. You'll see the shade in a moment. We have a situation with two thermometers next to each other. This one here is shaded and this one here is in the moonlight, and it's as simple as that. Let's move on and take another look. So here we show the setup a little bit more clearly in the right way up, and we're going to superimpose this with a low light picture so you can see the fact that this one becomes shaded and this one is open to the moonlight. Bear in mind the picture is low light, but I had to do that to make sure that you could actually see the contrast. Obviously this one is in full light, but I'll show you the moonlight picture in just a sec. And there we go. We can see that the one that we had is in the darkness, which is shaded by a chair actually, which you'll see in a later video. And this one here is in the moonlight. And this indeed is the moonlight, which even though I've upped the contrast, is quite bright, and you can see it's quite clear. Okay, let's move on and have a look at some of the flare footage that I took. I did this so that actually we can see the residual heat and how that works, and we can also see if there's any obvious heat effects before we actually look at the results from the thermometers themselves. The flare is an accurate enough device. It's forward-looking infrared is what FLIR stands for, and it would definitely show us if there was an effect from the moonlight. So I'll show you in this first little video here. You'll see my hand. I'll touch my hand to the ground, which is a stone slab, and you'll see the residual heat from my hand on the stone slab, which means obviously that if there was some cooling effect from the moonlight, that would definitely get captured by the FLIR. Here we go, I'll show you this very sensitive sensing device. And here we see my hand, which is absolutely glowing. Everything else has gone purple for contrast in this video. I put my hand on the floor, and there we can see on that stone slab the residual heat from my hand giving that handprint shape, which shows I only touched it maybe for 2 seconds, and it shows exactly how sensitive it is. And here we have a picture of the two probes. You can see both of the probes. They're on top of the stand that I've got them on. You can see them both purple at the ends, and you can see that there is no difference between them, even though this one, of course, is in the shade and this one is in full moonlight. And here we go with the FLIR device again. As you can see, no differences there. Right, let's move on and superimpose the FLIR picture on top of the normal light picture so we can see exactly what's happening. So this is a FLIR image that I've taken, and what I've done is I've superimposed it on top of the deck, and as you can see, it's just faded away and faded out. So we can see that the two lined up, there's no difference at all, and we cannot see that moonlight effect across there. Okay, let's move on and have a look at some results from this test setup that I've used. So we see here the results. We can see where I carried it out, we can see the date, and we can see all of the timestamps. And what we can see here is the results for the thermometer that was in the moon and the thermometer that was in the shade. And the experiment took place over about half an hour. I also have proof points where we've got the artifacts of the samples of both of these temperature readings, which if necessary could be shown. Okay, let's take a look at another example video and see exactly how I went getting these samples. Okay, another time check. Moon still out, shining down, chair blocking into our setup, and we've got 4.8, and we've got 4.8, and those are the ones that were swapped again. And of course this one here is the one that's being blocked by the chair. So I've got it exactly lined up, as you can see with this bit. So it's blocking it here, there's nothing else interfering with it, and the moonlight is falling directly onto this one. So as you saw there, I've got the chair. The chair is well away from both of these, so there's no shading effect from air currents or something. The chair absolutely blocks this one out, as the low light picture showed, whereas the moonlight falls on this probe. And so we've taken the temperature readings from these two probes, and as you'll see in a sec, I swapped those around. So here's the probes that are used, a little bit of a zoom in on it. Here we can see samples were taken on the 11th of November, and here's our timestamps, and of course here's the results that we get. Now, to tabulate this more easily and to show when the actual swapping effect taken place, I've graphed it. Let's take a look at the graph now. Okay, this graph is pretty interesting. It shows about half an hour of time, and it shows our results. So we've got time going across the bottom. We've got the temperature in degrees C going up here, and it ranges between what looks like 4.8 degrees C. It was quite cold out there that night when I was doing the sampling, and 5.4 degrees. And it seems to have got a little bit colder over that half an hour period. As we can see, the trend of the graph is downwards. Now you can see the star here. Star means when I actually swap the two thermometers over. So I actually have video footage, which I won't be showing here, but could if necessary, where I swapped the actual thermometers over. Now the reason I did that is if there was a small calibration error on one thermometer as opposed to the other, by swapping them over, we would see that error. And indeed, I think we do start to see it here, because when I swapped this thermometer, the one that had been 0.1 of a degree lower than the other went the other way. So as you can see, the shaded one suddenly went higher in its temperature, and the one that was in the moonlight suddenly dropped in terms of its temperature. And this is exactly when I swapped over the two thermometers. Interestingly, when I swapped them here, there was no change. So we have to average these things out. But I think what this effectively shows us that actually for most of the time, the thermometer that was in the moonlight was, if anything, a little bit warmer, not colder, than the one that was in the shade. So not surprising really, and certainly no great temperature differential between the two. Whether you take into account this calibration error of plus or minus 1, it averages out across the piece. So I think that's pretty conclusive evidence. So let's start to sum up. What are the key points here? Well, first of all, I think we want to look at the fact that most of the tests that are undertaken use a really poor approach and methodology, bad equipment and techniques. Secondly, I think any indirect or direct shading will distort the temperatures, samples that you have due to the wind cooling effects, and we saw that earlier. I think the third point is that the use of infrared thermometers with shiny and single test samples creates compounded errors from the sampling surfaces, the distance and the technique. Especially in those early videos we saw, they were only using one piece of metal. Yes, it was black. I don't know why it particularly had to be black, but they chose a black piece of metal. But they were sampling from one piece of metal.
In terms
so
of,
temperature will typically dissipate throughout the whole piece of metal. It would have been much better if they'd had individual samples rather than using just one large sampling piece. I don't know why they did in both of the tests. It's a huge way to introduce inaccuracies. And then finally, investigators can influence the results by touching or movement or placing or other effects relating to the environment that's being used. Indeed, when I was doing the experiment, I noticed that if I touched the end of the probe, it would bounce the temperature up a little bit. And so you can get some false positives in that way. I suspect the same can happen with the infrared thermometers, especially if they're touching the metal and messing around with it. So I think it's really important that the investigator doesn't touch things when you're doing these samples. And indeed, for all the data points that I took, that wasn't the case. Now, I said earlier that there was one noticeable exception. And this comes from the flat Earth itself. So I want to do a big shout out to Jeranism, because actually he's taken the bull by the horns, and I think he's come to some really good conclusions. And he probably goes against the tide of most flat earthers on this. So let's have a listen to what Jeranism has to say.
The night is cold, and items in direct cold air causes them to be cooler than items which are not directly in the cold. So if you want an example, when you're out during the day, well, the sun is very hot, which causes the air to be hot. And if you happen to be in the shade, so you're protected by the tree from the hotness, well, it's cooler because you're protected from the heat, which is the same thing but opposite happens at night. It's very cold outside, and therefore if you're underneath a tree, it's going to protect you from the cool air, which means that underneath that would be warmer.
Great ideas from Jeranism there, and I think he's got the nail directly on the head. So shout out to Jeranism for that. Okay, let's move on and have a look at some conclusions here. I think there's a few that we can draw. So I think the first is that there's no case for cold moonlight. It's just another example of poor experimental process and bias confirmation. I think secondly, flat Earth experiments tend to use faulty experimental techniques. They touch the thermometer, they shield using cover, they don't allow for the environmental influences, they're over complex, they use a bad choice of equipment, such as using the infrared thermometer. If cold moonlight exists, then scientists would have long ago noticed the effect and studied it. Can we imagine the greatest minds in the last 400 years having overlooked this effect? I don't think so. If we look at Herschel, Halley, Kepler, Galileo, Oort, Newton, Hooke and Boyle, all of these greats were also astronomers, and they closely studied the moon. They all looked directly into telescopes, which magnified the moonlight, and so I'm sure that one of them would have noted, at least one of them would have noted any unusual sudden cold effects. Cold moonlight is just another romantic notion that's been created by these fantasists. I'm known for being very tolerant of flat earthers, with all sorts of wrong ideas being spoken to me and me putting up with them. However, even I am tired of this particularly moronic suggestion. It's absolutely fine for people to ask questions, query things, and also undertake a first-hand observation and study of the world around them. I've got no problem with that at all. That's just sensible. But they should not delude themselves that they can successfully investigate complex natural phenomenon without the training, study, or statistical techniques needed. Not all science is simple. Much scientific investigation will be well beyond the equipment, skills, training, and understanding of the average person. And I think this needs to be accepted by the flat Earth. Just like we see with the flat Earth, the people claiming cold moonlight do so for very similar reasons. They want to feel special, they want to possess a secret that someone else hasn't got, and it's the romance of a magical idea that is beyond science, like White Rabbit said earlier. Okay, let's try and wrap this up with a summary and some takeaways. I think we can probably say that we have successfully debunked the claim that cold moonlight exists and has a cooling effect. So tick in the box there. I think secondly, this experiment was undertaken in the simplest manner possible to rule out any complicated setups or effects. The extract data was also collected during the testing with a flare device to see the thermal signatures and rule out any unseen issues. I think we saw very clearly with the flare device there was nothing hidden here, there was no effect going on. And finally, there's no evidence or substance to any of the multitude of claims made by the flat earthers around cold moonlight. So I think this wraps it up for another day.
Now thanks to everyone who's watched the video, and I hope you like the format, and I look forward to making more of these. I've been TOADY UK. Please finally like, subscribe and share this video series, and also my channel. Thank you very much.
Super producer.